Jai Hind everyone. The topic which we are going to discuss under blockchain architecture is Hyperledger Fabric. In Unit 3, we are having the Hyperledger Fabric, its component, how Hyperledger Fabric is being used in enterprise blockchain. So let's start with the topic. Blockchain. When we talk about the blockchain, then what are the application space of this blockchain? So we can say that it is a design pattern made famous by its use in Bitcoin, but beyond the Bitcoin, it has its application in other areas also. So we can reimagine the blockchain, how this blockchain handle the world's most fundamental business interactions, and how this blockchain opened the door to invent new styles of digital interactions. So when we talk about the blockchain, in the earlier lectures also, we have discussed that blockchain is not limited to the cryptocurrencies. It is having its usage, its application in other areas other than cryptocurrency. For example, we could have we could use the blockchain for managing the identities, for managing your business applications, and so on. Nowadays, many enterprises, they are adopting the blockchain, and they are adopting the adoption of blockchain is for a wide range of applications. So when we say the blockchain opportunity, then Bitcoin is only this smaller part of this space, and we are having other applications also where we can use the concept of blockchain successfully. And why we are able to use the blockchain? Because here the very first thing, it is decentralized in nature. It is immutable. You cannot make the changes once you have done the transactions. Then transparency. Also privacy and security. The algorithms which we have used in blockchain, the privacy and security, they are the inherent part of it, because in the blockchain we use many cryptography techniques with the help of which privacy and security can be achieved. This is a simple example where we are not using the blockchain. Here what we are doing, we are transferring the property or the asset from one party to the other party. Now, what will happen when we are transferring the the asset from one party to another party? Let's suppose party D is transferring some asset, maybe a car, a vehicle, to the party A. Then we need to update the records of the party A. For example, license number, it could be your car registration number and so on. Then you need to update the records of party A. Then we need to update the records of bank. Then all these things, they need to be assessed or audited by some auditor company. Then we require this. The document need to be stored here. So here also we are having some database. Here also we are having some database. Here also we are maintaining the copies. Similarly, here also party B's records, and if party B is selling to some party C, then again we require some record keeping mechanism over there. So it is quite inefficient, expensive, and it is also vulnerable to attacks. So this is the traditional system. Now look, see what will happen if we include the blockchain in the system. So here what we are doing, we are keeping a single copy of the blockchain on all the locations, and this copy of the blockchain is same on all the locations. Here what is happening? Here this record is exclusively meant for this. Here this record is exclusively meant for this. The auditor needs to access all these records if it want to do the auditing. So here the complexity in the system is being arisen, and it could be avoided with the help of the blockchain, because we are aware that blockchain decentralized, immutability, transparency. So here if I'm transferring something to this party and the blockchain got updated here, then this same copy is being also, the changes being also reflected here with the help of consensus algorithms and all these things. So here it will give the agreement among all the parties involved here. There is a provenance, immutability, and ultimately the most important part, there is a finality of the transaction. So what are the benefits of blockchain for a business? The very first thing, it is a shared ledger. So append only distributed system of record shared across the business network. We can only append the records here. We do not update the records which have already been stored in the blockchain. Then security. We are using appropriate authentication mechanisms, verifiable mechanisms which we used in cryptography. So we are using the cryptography techniques here with the help of which security can be achieved. All parties, they agree to the network verified transaction. So there is a common consensus among all the parties involved. Then we are having the digital contracts which we call here the smart contracts. These smart contracts, they are having some business terms embedded to them. So if a particular event occurs, then these smart contracts, they executed automatically. I don't need to generate an exception for it if something happen in the network. For example, let's suppose in a supply chain management system, if the tomato or the potato is being transferred from the central storage system to the vendors, then the capacity, the actual number of potatoes is being, you could say, it is being decreased. And if some other farmers, they are waiting for the storage to store their things in that particular storage facility, then automatically the alert, they may go to their apps if they are connected with the mobile app to that particular blockchain, and automatically they come to know, okay, some space has been created, now they can transport their goods to that particular storage facility. So such kind of things, they are already predefined as a logic in a smart contract. So here, what are the benefit we are getting? Reduces the time, transaction time from days to near instantaneous. It removes the cost, it reduces the risk, and it enables the new business model. That is, we can integrate the IoT. For example, we can integrate the IoT with the supply chain management system. For example, the example which we had discussed just now, that is in the storage facility. How I will come to know that some space has been created, or some we can store new things in the new goods in that facility. I can use IoT sensors. So I can integrate the IoT sensors with my blockchain applications, and these blockchain based applications I can use for the SCM purpose. Degree of the centralization, this we have already discussed, that in typical system we are working on the centralized ledgers, and with the permissionless public shared system, for example in Bitcoin, we are moving towards the decentralized. So here 100% centralization is here, and whereas here we are having the 100% decentralization here. So this slide is showing the basic difference between permissionless and permission. Many times we have discussed all these things, but it is just for a revision purpose. So my permissionless, when we talk about the access, then we are having open read write access to the database, whereas in permission, the participants, they need the permission if they want to perform any read write activity to the database. Scalability, we talk in terms of scalability. In permissionless, the scalability is very high, whereas in the case of the permission blockchain, scalability is low, but whereas here the throughput of the transaction is low, and here the throughput of transactions is high. Because why? Because here the participants, they are already in a agreement. So here, once they reach to a common consensus, they don't need to provide a proof of work. They can easily add the transactions to such kind of system. Consensus here, we have already seen proof of work, proof of stake. Here, the consensus algorithm, generally it is a closed membership consensus algorithms. How we are maintaining the identity in permissionless, it is anonymous or the pseudo anonymous, whereas in the case of the permission, identities of nodes are known, but transaction identities, they can be kept private, anonymous or pseudo anonymous depending upon the requirement. Asset, here the assets in permissionless is native assets, whereas in the case of the permission, any asset, data or state, it can be stored in the blockchain. So for such kind of enterprise blockchain, that is for this case permission blockchain, we are having a Hyperledger, the Linux Foundation, it formed a Hyperledger project group. It is a collaborative effort which is created to advance the blockchain technology by Linux by identifying and addressing important features for a cross-industry open standards for distributed ledgers that can transform the way business transactions are conducted globally. And here, under the Hyperledger project umbrella, these are the various components which have been created under which are performing under Hyperledger project. These are the Hyperledger members. So we are having premier companies. For example, we are having Accenture, we are having IBM, we are having associates, and this is just a partial list of the members who are working under the Hyperledger project group. So Hyperledger Fabric, it is a distributed ledger platform. It is implementation of blockchain, that is a foundation for developing blockchain. That is, when we go for the developing blockchain applications, we generally do so with the help of Hyperledger Fabric. It emphasizes on, it is work on ledger, we can design smart contracts, we can go with the consensus algorithm, confidentiality, resiliency and scalability, they are part of the Fabric framework. The very first version was introduced in July 2017. At that time, we are having 159 developers from 27 organizations. It is an open source community, and basically the focus is on enterprise grade blockchain deployments. It is a home for various distributed ledger frameworks, including Hyperledger Fabric, Sawtooth, Indy, etc. Open source community focused on enterprise grade blockchain deployments. And what are the things? Different companies, organizations, they want to collaborate. We are having a closed group, that is members, they know each other, but the trust factor is not a mandatory. That is, they can come together, they can work together, although there is no trust value among them, but still with the help of the inbuilt inherent features of the blockchain, they can come together and work. Distributed shared ledger is there, that is, and it is basically based on permission consensus. So these are the few projects. For example, when we talk about the Hyperledger Cello, it contains the tools to serve as operational dashboard for blockchain. When you want to design a permission enterprise blockchain, then you go with the Fabric. If you want to work on the identity management, then you will use the Hyperledger Indy. If you want to use the permission EVM based things, BFT consensus kind of consensus algorithm you want to work, then you can use the Hyperledger Burrow. Now let's start with Fabric part. It is open source permission DLT platform. Here the thing is that it is a modular blockchain framework designed for developing blockchain-based products, solutions and applications using plug-and-play components that are aimed for use within private enterprises. Pluggable components, we are having pluggable consensus algorithms and membership services. Smart contracts can be designed in Hyperledger Fabric with the help of general purpose languages, for example, Java, Go and Node.js. That is, you don't need extra programming effort, extra effort to learn some other programming language. If you are aware of the Java, Go or Node.js, then you can work with the Fabric very conveniently. These are the benefits of Fabric. It is a permission network. Participants, rather than open network, they are working in a closed environment. Confidential transaction is there, pluggable architecture, and easy to get start. Let's come to the Fabric architecture. Here we are having the, in the Fabric architecture, we are having the component. This is the client application. It is interacting with the blockchain with the help of the Fabric SDK. Now this Fabric SDK, it is responsible for interacting with the blockchain, and here the blockchain, in the blockchain, I am having peer nodes. These chain code is nothing but it is a smart contracts which are written for in the Fabric. The peer nodes, other than peer, this is the organization. These peer nodes, this is my blockchain, and this is the world state of all the transactions which are running over there, and this is being maintained at various orderers. So here what is happening, the peer nodes, if they want to, for example, organization 1 wants to interact with organization 2, whereas organization 2 wants to interact with organization 3, and their interest, they don't match each other. So organization 1, they can work on organization 2 on channel 1. Here they are using the blockchain components which are meant for this channel 1. Similarly, here we can have the channel 2 and so on. So here the peer nodes, they can be connected to different blockchain ledger, and corresponding to each blockchain ledger, the different channels they can be provided. To authenticate the users, we are having the local MSPs who are authenticating and verifying the peer nodes. So these peer nodes, they are responsible for working on the blockchain, but they cannot work directly on the blockchain. Here we are having the orderer nodes. So these peer nodes, they will send something to the orderer node on a channel on which they are connected with the orderer node. Now these orderer nodes, they are maintaining some part of the blockchain, and they are interacting with each other. So here the components, as we have seen in the figure, it comprises of ledger, smart contract which we are calling them as chain code. Then we are having peer nodes, ordering services, channels, and Fabric certificate authorities, that is my MSP. Ledgers, it is my distributed ledger which is being maintained. Smart contracts, they are referred to as chain code. Peer nodes, network entity that maintains a ledger and runs chain code containers in order to perform read-write operations to the ledger. Peers are owned and maintained by the members. Ordering services manages the global ordering of transactions. MSPs, they manage the user identities and authenticates clients. Channels, each channel has its own policy rules and is governed independently of other channels. Network policies and identities are there. This is a simple figure which is showing the Fabric smart contract, that is the chain code. So here we are having the seller organization 1, organization 2, and this is the chain code which which is being operated between these two organizations. So if I go with the organization 1, then application here, what is seller is organization 1, buyer is organization 2, and there is a transfer of car 1 to seller to buyer, and this transfer is being written over here. Similarly, we are having here, so both these two can interact with the chain code by using their own system calls. Fabric transaction flow. This diagram is showing how the transaction is being done in the Fabric environment. So here what is happening, first one, we collect the transactions, that is peer nodes. We are having the client, we are having the endorsing nodes, and we are having the orderer nodes. We could have multiple orderers and we could have multiple endorser nodes. So here what is happening, first the client will generate the transaction, and it will send the message that a transaction to be endorsed to these endorsers, and it will broadcast to them endorsement that satisfies the endorsement policies. and it broadcasts the endorsement. That is, it will broadcast the things to all these endorsers. Now, what these endorsers do, they will check the validity of the transaction and also check that these transactions being in accordance with the endorsement policies. Once everything is okay, then they will return the result to the client. Now again, at the client, what the client will do, it will see at the majority of the answers it is getting. On the basis of the majority of the answers, it will take the decision. Let's suppose all the endorsers, they validate the transaction. If they validate the transaction, then it will broadcast this endorsement to the orderers. Here the orderers, what will do, they will verify the endorsement again. They will read set. If okay, then apply the write set to the state. Similarly, and it also send the things to the committing peer node, that is CP1, which will update the state in the blockchain. And also order will broadcast this thing to all the entities who are being involved here. We can write the Fabric chain code in Go, Node.js or Java. It runs in a separate process from the peer. Fabric contract API is generally being used in the Fabric SDK, that is at the client end, and contract interface, a high-level API for implementing chain codes. We could have the code, Node.js, Java. These are the links where you can go and study the things related to your Fabric chain code. When we talk about the Fabric application, so at the client end, we are having the application on which what we are doing, we are running this Fabric contract API. Here, the application developer identity will be verified. It will run the smart contract. This is my blockchain network. These are smart contracts. Here, all the peers and orders which we have already seen in the previous slides. That activity is being taken, and after that, it will receive the ledger update. So here, what we are having? We are having this concept on the right hand side of the things. This we have already seen, and these are the sites from where I have developed the Fabric slides. So this is all the introductory part of Hyperledger Fabric, how the transaction is being done and the Fabric architecture. Thank you.